All right, welcome back, Principles of Engineering. This is part 2 of the variables, lessons 3.1.5. So let's get started. We left off with how to do integers and how to use a counter right here, and that's where we finished. So now we're on to variable application number 3, and I'm not going to do every single one of these, but this is how to set a flag. So for example, an observer could use this for 5 seconds and it could remember whether a switch was ever pressed, even if only briefly, and that is through Boolean logic. So we have bool touched right here, and so I'll go ahead and type these out just so you can see it over here, but underneath the task main, bool touched, and what I said is basically I'm saying bool is touched. This is the flag. So I'm telling the computer that the flag you're looking for is whether it's touched or not. Now next is clear timer. And clear timer, and I'm going to use T1, so timer 1. Semicolon, and I forgot the semicolon above. Next, touched equals false. So I'm saying currently touched is false. Touched equals false. Okay. And while touched equals false, it's going to jump into this while loop. So I'll make my while statement while, and we're going to use time 1 and T1, and you don't have to type all these out. I'm just kind of giving you a visual representation of what's going to look like. Less than, and once again 5,000 would mean 5,000 milliseconds. I'll close that out, and then I'm saying within the while loop. So touched equals false, and while it is false, let's jump into this while loop. The while loop being if, my goodness, if sensor value and we're going to use the bump switch, sensor value bump switch, parenthesis equals 1, close out the parenthesis, and then what to do if this if statement is met. And what we're telling it to do is if you sense the bump switch being touched within that 5-second period, touched will no longer be false, it will be true. All right, and basically what we're telling it is to record that, so someone could go back and look and be like, ah, yes, it was touched, because touched is now true instead of false. So there is your code that would fall in here. I'm going to go ahead and fix the formatting. That looks good. Compile. The robot is not on, which is a problem. It has all these issues. Alright, so there's a bunch of expected things. So what we're going to do is we're going to open this and we're going to add a second curly brace down here. Because after the task main it looked for this curly brace, and since there was no curly brace, technically the code wouldn't start until after the while loop, so I was kind of confused that there wasn't any curly brace here. Let's go ahead and fix that formatting. Now let's try this compile. Okay, if sensor value bump switch equals 1, I forgot this parenthesis here in front of sensor value. Compile. What is wrong? Bump switch is, oh, I have bump switch instead of bump. That could be an issue. Compile. And substitute similar variable bump switch for bump switch. Okay, so capital S. Now we're good. We downloaded the robot. Okay. Okay, cancel. I'm gonna unplug this real quick and plug it back in to the robot. And sometimes you just gotta mess with this here. We're gonna turn on that. And robot. We're always gonna go back here and make sure this is all right. So right now, you always have to go back to robot and make sure that you've changed robotics to the 2.0 Cortex, and the platform type is also natural language. That's going to change things. So once I click start here, all right, and I haven't yet figured out where to figure out where it will tell you if it's been touched. I just know that it does. So I'm gonna hit start here, and for 5 seconds it's gonna look. I pressed that and it stopped the program. Start, and I'm looking for where it records this. Site sensors, switch, timers, and program. So you can see that it went for 5 seconds long. I would personally shy away from Boolean logic just because we don't use it that much currently. Instead, you could use integers. So that's setting a flag. Application 4 is to remember a maximum value. So I could rewrite this similar code here, and instead of using a Boolean, I could do integer. So before our task main, I would do integer most, semicolon. Sometimes I'm not quite sure if you can clear the timer before you get to the task main, but we'll figure it out. Clear timer, T1, semicolon, most equals 0. And then what we're doing is a while loop. And if you look at this code, pretty much it clears the timer, and then while the timer is less than 5 seconds, all right, check this. So sensor value, it could be the potentiometer, it could be the optical shaft encoder, it could be the sonar. All right. If the sensor value is greater than whatever was last recorded as most, then most will now be that new value. So that will change depending on whatever most equals. And once we have this, if sensor value bumps, so sensor value, I think I have it called potentiometer. Potentiometer is greater than most. If this is the case, then most equals sensor value. Potentiometer. That's a semicolon. All right. And compile. Got an issue there. So I can't put that there for some reason. So let's go ahead and copy those. And then I will put that after task main and after the first curly brace. So enter that. Okay, compile. Oops. I gotta delete those two. Missing semicolon. Compile progress. So if you look down here, the debugger window will kind of give you some advice. So let's go here. Compile, download the robot. Go ahead and start that. And the sensor is right now at 3, and I was greater. Let's up this to like I don't know, 10,000 seconds, so that now it's 10 seconds instead of 5. Gives me a little more time. Okay, so I'm moving these here, and if I look at my variables, it's remembering what was most recently recorded. I'm going to start this again. So most, and my value can't go any more than 4,095. So I'm going to turn this all the way down, and you'll see that once I press start, it reads 2, and it goes up, 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 and then I go down, and it's still going to remember the highest value that it was at. So that's why I would recommend using integers more than flags at this point, and let's move on with that. So this could be used to figure out runtime errors. Slowing down a program with the step debugger is typically impractical, but using a variable to remember and report which parts of a program were executed can be helpful. And we're not going to worry about debugging a program. If you want to look through it, great, but not something we have to worry about. Global variables and local variables. Think of this as something being saved to your computer and something being saved to the cloud. A global variable is more like in the cloud, whereas a local variable would be on the computer or the robot itself. Local variable can only be read in certain places, whereas global variable could be read in multiple. And going on from there. So, like I said, global can be read or changed from any task or function in a code, and value can be seen or read globally. All right. Local variables belongs only to the task or function in which it was created. Value can only be read or changed from within that task. Now, the difference is if you put a variable above the task main, that makes it a global. If you put the variable below the task main, that makes it a local variable. All right. Typically, that's how that would work, at least in the most basic of senses. So you can create a local variable by declaring it within the task main curly braces. Down here, integer rotations is below the task main, so it is a local variable. To create the global variable, the integer rotations comes after the pragma codes, but before the task main. What is a function? A function is something that groups together several lines of code. For the purpose of this assignment, it's just to show what it is, but if you were doing something that was thousands of lines long, and you had some lines, instead of having to type it multiple times or copy and paste several times, you can write it one time, define that function, and then call on that function later again. So let's go over a simple one. So LED is on if bumper is pressed, off if released. So if we go ahead and clear this here and leave these curly braces, and I get rid of that integer, I'm going to type in void LED control. LED control. Now, what that is LED, you could name it whatever you want, but basically the void is like, hey computer, don't worry about this right here. I'm just defining my variable, LED control, parenthesis, open parenthesis, close parenthesis, semicolon. So that's my function prototype. Here is my function. Computer, don't worry about it. It's nothing to worry about right now. We'll worry about it later. Afterwards, we have the task main, and we have our open curly brace, and then let's do our while loop. So while 1 equals 1, and close that bracket, do this. So I'm going to open up my curly brace, and let's say activate command LED control. So now what I'm saying is call on the previous function that I told you about, LED control. Parenthesis, close parenthesis, semicolon, and close squiggly bracket. And I'm going to fix the formatting here. And then after that, I'm going to type in void underneath LED control. And open parenthesis, close parenthesis. And now I'm going to tell it what is void. So I'm going to make this program called LED control. And think of it as a subprogram. So I'm going to call this subprogram LED control. I'm going to say whatever it's supposed to do. And then up above in the task main is where I will change. Basically, I could write like a 15-line code and then turn it into one line, so I don't have to keep on typing those 15 lines again and again. Right? So void, do an if statement, if sensor value, bump switch, close parenthesis, equals 1, close. Then do this. And what we're going to do is if the sensor value of the bump switch is 1, then turn on LED. Turn LED on. What do I have? If this is the case, I can do this. Now let's look at this. Turn LED on. And we're going to call that LED. Oh my goodness. Okay, turn LED on. And let's look at what I called my LED because I can't remember. Green. I called it green. So that's the name. So we're going to call it green. Parenthesis, semicolon, close the bracket off. Else, and now I'm saying otherwise do this. So the else would be the turn LED off. And we're going to refer to green again. Semicolon, close bracket, and close off the void. So fix the formatting. Okay, compile the program. That should be good. So download the robot. So now I'm running a while loop, and if you look down at my robot, you'll see the green LED, not the LEDs of the Cortex, but this LED here. Okay, and if I press the bump switch, it should light up. The controller is not on, so let's try this. My battery died, of course. Let's get a different battery real quick. And we're back. Okay. So let's try this again. Compile the program, download the robot. Try this again. And sometimes you just gotta unplug it and plug it back in again. So I'm starting the program. I should be able to press this bump switch and the light turns on. If you look here, bump switch, bump switch. All right. So that's what you need.